Right? Let's start with our discussions today. By the way, we are remaining with about 2 weeks to go for your 2 weeks for you to go for grace period week. You'll be given 1 week for studying discussions that, so we're about to do that. Um, but yes, what we want to learn today, I think we'll do it very fast. We don't want to leave anything until we want to do it fast. Let's look at functions. So we'll go to functions, and then we'll go to linear functions, and again we may go to nonlinear functions, which I feel we are going to do that, nonlinear functions. So let me start these functions. So we'll look at one, the concept of relations and functions. Two, we're going to look at the graphs of functions and its types, range as domain of functions, and then we will proceed to what are called the quadrants, if time will be there. So I think we can look at that. All right, but what we are starting from, we are starting from this issue of variables. We are starting from the issue of variables. All right, so our topic is on functions. We'll be looking at functions, relations and functions. Business maths. So look at relations and functions. And functions. Relations and functions. That's what I want to look at today. All right. Consider an example. Consider this scenario where someone is a salesman, man's monthly pay, and this man, he draws a basic pay of 15,000 kwacha and he gets a commission of 200 kwacha for every unit of goods sold or goods sold. So he does this for 1 month, right? And so out of that, we can generate what variables for there, so that maybe if you want to find what will be the pay after this amount, after he has sold this, how much is he going to obtain when he sells this. So that becomes now an equation in terms of what are called variables. Unknown number becomes what are called variables. So in mathematics, what we actually do is using that scenario, y is equal to 15,000 kwacha plus 200x. Right? That is what is called an equation. But this equation, where you have got, So the issue is, I think they are saying you have to consider a salesman's monthly pay. He draws a basic pay of 15,000 kwacha and he gets a commission of 200 kwacha for every unit of good he sells during that month. All right. So the variables are these. So this is a variable. This is a variable. A variable is a known letter that you can find the value. So it affects the other variable. So one variable, it is something that it works with the other variable. For example, if this variable, this is y is being defined like this. All right. So it is, so y is being defined by that. So we have got dependent variable and we have got independent variable. The y being the fact that this everything will depends on the value of x there. So we have got that being independent variable against dependent variable. So one is an effect, the other one is a cause. In other words, one variable you can turn out in this context what will happen when you change this unit. Assuming that x is 2, you are going to affect the other side. So the one that you are going to change is going to be this x. Assuming that x is 1, x is 2, x is 3, x is 4. Whatever is coming out of that is going to affect the other one. Therefore, the fact that one you are changing, the other one is a change, the other one is a cause, or it has got an effect. So this has an effect on y. So, for example, assuming that x is 1, if we take x being a variable, x equals to 1, what will happen will be y is equal to 15,000 plus 200 multiplied by 1. All these are quantities. So y is equal to 1500 or 15,000 plus 200, which gives you y is equal to 15,200 kwacha. So this is, you can see that whatever you are changing here, is going to affect the value of y. So that becomes a variable. So this is a variable, this is a variable. So the unknown one becomes a variable. But this one has got an influence, it is affecting this one. So whatever we are changing there is going to, assuming that this is 4. So if this is 4, this is going to be 8. 200 times 4, it is 800. There's going to be like this one. It's going to change. Assuming that this is 10. So here again it's going to affect this one. It's going to be 2,000, and here it's going to be 17,000. So that is a variable. So this is a variable here, and this is a variable, right? So that is what I wanted you to know about these variables. That again, you have to know that they have an impact on the other side. All right. So we can define this in what is called relation terms. So let's define that in relation terms. So that's why we are looking at the word relation. Relation, it means that there is a relationship between these variables and the other one. Therefore, the issue of relation is coming in. Now let's go to the relation. We'll do it very fast because we're already late. The elements or members of a set which can be related with each other in any form is called relation. In other words, an element or members of a set, those are children from that set. You learned about a set. So in a set, there are children or there are elements or there are members. So those ones are now, they will form set X. So if we have two sets, assuming we have got set P and again we have got another set Q, then we can also relate the members of the first set P to the other set Q. All right, and this is called relations. In other words, you can have set A, with its element here. All right, you can have set B with its element here. If we are to compare these two sets, if we are to compare this set, or if we are to relate, if we relate set A and set B, then what we are doing there when we are relating, when we are comparing, that is called relation. Relation is coming in because you are comparing two sets. Set A, set B. The fact that you are comparing these two sets, that becomes what is called relations. All right? For example, let's define relations in terms of set P and set Q. Let's say set P, let's look at set P. Let's assume that set P has got these elements. Set P has got elements like A, B, C, and D. They have got 4 elements, all right? That is set P. And set Q has got elements 1, 2, 3. Let's relate that. Therefore, the relation, which is, we are calling it R, all right? We are taking each set and then joint them together. So what will be the relation of R? So look at the relation of R, all right? Relation of R. The relation of our set R is equal to the several sets there. So R is given by, okay, we've got set A. We can relate this, all right? We are relating, all right? We can relate. We can, in other words, you can set A, 1 set B, 2 set B, can be 3 set D, can be 1 set D, can be 3, sort of like that. In other words, you are taking A times you are relating to 1, and you are taking B and you are relating it to 2. You are relating another B to 2 to 3. You are relating D to 1. You are relating D to 3. In that context, that is a relation where AR1 means A is related to 1, and BR2 means B is related to 2, and so on and so forth. When you are relating, if you are to relate, what does that mean? To relate, what does that mean? You can relate B to, all right? You can relate C3, all right? You can relate D to 1, all right? You can relate D to 2. So that is a relation. Relation means that you are bringing these sets, you are bringing them together so that they work with each other. That's what is called relation. A is related to 1, B is related to 2, but C is not related anywhere. It's only D is related to 1 and D is related to 3. C is not related anywhere. Why do you think that C is not related anywhere? All right, let me just put them down. Let me just put them down. Why they are talking about that it has been related. Saying A is related to 1, B is related to 2, and again B is related to 3. All right, and again we have got D is related to 1, and again D is related to 3. What does that mean? What does that mean? All right, let's look at, let me define this. Let me read again the definition of a relation. All right, relation, the elements or members of a set S which can be related with each other in any form is called related. But if we have two sets, set P and set Q, we can also relate the members of the first set P. We can relate the members of the first set P, all right, to the other members of set Q in any form. So set P, you can relate it to this set in any form. You can relate that in any form. And they are calling this as relation. Example, that set A, B, C, and D elements with a set 1, 2, 3. 1, 2, 3. Do you get what is happening there? Huh? How many elements are in set P? There are 4 elements. How many elements are in set Q? 3 elements. Then we want to relate. To relate, which is our error. The question will be, why have they taken out element what? C. Why is it that element C is not inclusive in the set? Huh? It's not related. Now, if it is not related, so this is related to this. This is related to this. And 3 is related to A is related to 1. B is related to 2. And again B is related to 3. D is related to 3. And again D is related to 1. But C is not related. Why do you think that C is not related? Why do you think C is not related? All right. I think we'll come back to this when we look at the domain, because where you are looking at domain, the other elements you don't include in the domain and the range. You leave with them. I think this will take us to an area where we are looking at the domain. Let's switch off our mind from this one. We'll come back to this one. Let's go straight to functions, and then we'll come back to again to this one, right? Let's go to functions. Maybe we can take that. You know what functions are? Do you know functions? That functions have got domain and have got what? Range. All right. Let's go to that. All right. Let's go to functions. We'll come back to this again. Let's go to functions. Functions. We'll come back to this. I think it's going to take us to range. Let's go to functions. So functions is to do with input and output. You know what input is? Do you know what input is? What is an input? Something that you want to do. All right. So an input has to produce an output. All right. An output is the results. All right. So an output is the results. The input is what you are pumping in. All right. You remember at first I had to put something here. I actually said y is equal to 15,000 plus 200x. All right. What is our input and what is our output? If you look at that, what you are putting here, this is your input. Whatever you are putting, assuming this is 1, assuming this is 2, assuming this is 3. So this is the input. What you are going, the results is the output. All right. So this is the what? Input. What you are putting here is the input. All right. But the results, the answer you are getting is the output. All right. So the output is the resultant. So resultant, or we are looking at the results. Results is the output. So there's the two you have to look at, you have to think of. So when you look at input and you look at output, they are different. Assuming we have a machine, and this machine, it needs materials. You buy raw materials out there, you put them in the machine for it to process. So we have got the input, and what is coming from the machine, that you are able to see something which has already been processed, that is the output. Are we together? All right. So if we call the first term of a member of any relations as a domain, that's why I was saying I'll come back. Now, if you look at the first member of any relation, that one is what is called a domain. A domain is the same as the input. All right. So we have got input is a domain. The word input is the same as a what? Domain. All right. So the domain is the input. And the second term of the member of the relations is what is called the range. This is the first member, right? The first members. And the second members are what is called output. And the output is the same as the range. So you have got the range. So output is the range. So we'll look at into that. So we have got the input. So the input is our x. All right. So input is our x. Input is our x. And output is our y. All right. So output is our what? Y. What we are able to see, something that you admire Assuming, for example, right, a child, a baby is here. So you find that for a baby to grow, there are a lot of variables: food, water, right, refreshment or whatsoever, happiness. So this, if you give the baby less food, it's going to affect the baby. If you give the baby less water, it's going to affect the baby. All right. Intelligent. Let's look at intelligent. Let's look at, for you to be intelligent at a school, at a university. Intelligent, it is your, assuming the intelligent is here. So intelligent, for one to be intelligent, there are a lot of variables, there are a lot of factors. One of the factors for you to be intelligent, it is the environment. All right, the environment where you are coming from. All right, assuming the environment you are coming from it's something which is very, very drastic environment that even yourself sometimes you ask, why is it that you, God, you allowed me to be in this family? All right. Of course, sometimes there are other things we have to accept, right? If we can't accept, that's why people are hanging themselves. We have to accept. So, intelligence is to do with the environment, all right? It's to do with the freedom that you are given at home, all right? Because sometimes there are other families which are very strict with their children, right? You find they are strict, but the strictness is useless. Right? You find they are stricting against you. They are saying, no, we wanted you to be at home when the moment you come from school, be at home, all right? Then you can say, you can become coming up with the mathematics. Why is it they are telling me that every time I have to be at home at 5? Then you go there and you make your hypothesis testings and what, all right? You test and you discover things are bad. You see, so it depends. So intelligence, environment, what. So you change this. The moment you change this, in other words, the intelligent is your output. The input is this, what you are bringing in. The input is the X, whatever. So the X are affecting this. The environment, good environment is affecting this. Less water affecting this. What is affecting this one? That's why we are looking at input and output. All right? Input and output. Cotton. If you grow cotton on its own, it is input. Cotton, because when you grow cotton, you can't say you have grown clothes. It's not. If you grow cotton, then you can't admire that I've got clothes. It's not. Cotton is just a plant. It's a plant, but it has to go to machine for processing. So therefore, that cotton is the input. So the cotton is referred to as an input. So this input has to go to machine for processing. And the fact that it goes to machine for processing, then what comes out of it is a shade from the machine. So you have got input. So you have input here, input there, which is your X. Out of this, you have got a factory. The factory is here. It's your F, all right? And I've got here out what? Output. And your output here, it is Y. It's your Y, all right? Y. So you have to put the input there, and the output, which is your Y. So the output is the Y. Because this output is what you actually see. So the output is the range. This is the what? Range. The input is the domain. So domain is the input and the output is the range. Something like that. So F is the factor where you have to process. So a function usually represented as f. As we can see in the above, when f acts on input x, we get x as output. So every often we write the function. What we do is when we are writing this function, what is happening here, we say y is equal to f of what? X. Talwa kumasamu so far. This is now mathematics now. Now function. What I have explained there. It is y is equal to function of what? X. The way we read here, hey, those who are sleeping, but I can't sleep because the conditions are not favorable here. All right? Right. The way we read here, we are saying y is a function of x. Right? We are saying what? Y is a function of y is a function of x. What does that mean? Which one is our input and what is our output? Our input, in other words, you have to pump in here to get the results here. If x is 1, x is 2, x is 3, what will be y? So this is a function. So like y is equal to 3x plus 4. This is a function. All right? Assuming x is 1, x is 2, x is negative, x is 5. You can get the values of y, right? Is it? As it if you put x here to be 0, the whole 0. So y is equal to 4. All right? When x is what? 0. When x is 1, y is equal to 7. When x is 2, y is equal to 10. When x is 3, y is equal to 13. I don't know whether do you get where we are getting 10, 13, what? No. Huh? When x is 0, the whole this will be 0. So y is equal to 0 plus 4, 4. When x is 1, 3 times 1, 3, plus 4, 7. When x is 2, 3 times 2, that's why the issue of range and domain is what? That's why when you were in secondary school, before you came here, I still remember that you had something like range here and domain. All right? Function is y is equal to 3x plus what? 4. And we are saying if a range, if suppose this one is 0, if this is 1, 2, 3, you are substituting, right? You are doing like this, right? Yes. So said 0 here is going to be what? 7. And here is equal to what? 4. Here, 7. This one, 10. This one, 13. All right? And then they could say, find here if domain is 10. Right? Given this function, find what is here. Right? Where you are saying y is 10. So you are putting 10 here. Right? So you are saying 10, this 10 is this one, right? Is equal to 3x plus what? 4. And this goes there, right? So it's going to be 10 minus 4 is equal to 3x. Then this one minus 6 is equal to 3x. Then x is equal to 6 divided by 3. Then x is equal to 2. That's why here it's going to be what? 2. You are doing something like that, right? Huh? Good. Let's proceed. Let's proceed. All right, let's proceed. So what you have to take there, what I have said is about the issue that I've said about f of x. So we can also use arrows diagram to represent a function like these arrows, right? You can do that, right? Let us have two sets, x and y. Then f is called a function from the set x to the set y if if another one is this one, f such that x is y. That you see, it's again the same function of x mapping to if this it is mapping to this y. That is what they are saying is that let us have these two. We have got two sets, x and y, set x and set y, right? So f is called function or function from the set x to the set y, such that f, in other words, f function such that x maps to y, such that x is a function of x mapping to y. That's what I'll give you an example. Let's look at an example. We are now coming back to those examples. X has got an element of A, B, and C. And Y has an element of 1, 2, 3, and 4. Let's present that one in a mapping 4. Let's look at that. Let's look at these two sets. Let's go to set these sets. We are moving. If you are, some of you, I think we have left you behind. Okay, it's up to you to be still behind. All right, let x be a set. X equals to, is a set of A, B, and what? C. And the set y is a set of 1, 2, 3, 4. I'm not talking about union or intersection here, right? You learned about union, yeah? Right. I'm not talking about union. I'm not talking about intersection. But we're saying now, let's look at these two sets there. And let's map. Let's use mapping here to find whether we are mapping. So arrow diagrams for a function f from x to y is given like this one. So you have something like this. Right. This is what? X, eh? This is y. All right. Because range, this is range, eh? And this is what? Domain. So I've got a function A, B, and what? C. So A, B, and C, this one is 1, 2, 3, and what? 4. And want to play with the function. So if you look at this one, all right, it's easy. You can say one can map to 1. It is possible, right? Possible. All right, it's possible. And again, if you look at this one, assuming that B has mapped to 3, B you can map to this one if you want. All right, and if you know what this one, you can make even C to map to this one if you want. All right, you can do something like that. So you can see that these elements here can find friends here. All right, all right. These elements here can find friends in this one. But if they are finding friends in this one, because there are 4 members here, it means one member is going to be a bachelor. This one has been mapped to this. This one has been mapped to this. This one has been mapped to this. All right. And one element cannot be mapping. It can't map to 2. Right. Then that is a problem, right? but it has one element at a time. All right, one, right? And you'll discover that one is isolation, has no friend. Then that's the issue of mapping comes in. Where you are mapping, an arrow indicates that that belongs to the other one. That's why they have got that arrow. Okay, let's proceed. In this example, we can write domain, range, and codomain of the function f. What does that mean? You have got, we can write domain, range, and codomain function of that. So domain is, if like this one, this is a domain and this is a range. This is the domain and this is a range. This is a domain. And this is a what? Please. It's a long time I did this. I think you are be reminding me because you're just coming from school. You're just coming from university. You are from secondary school. All right. Now, what I was referring again, it has disappeared. All right. In this example, we can write the domain, range, and codomain of the function f. Domain is A, B, C, set X. So this is our domain. Range is the results, right? So this is our domain. This is our domain. Domain. And this is our what? Range. But the function is the codomain. Codomain. Now, when we talk about domain, it's A, B, C. So talk about domain is A, B, C. And our range is 1, 2, and 3. And our codomain is the 1. So the codomain. So you are looking at it. They are bringing another issue. They are bringing another issue. They are saying, if you look at this one, they are taking this one to be a codomain. So they are saying codomain. They are saying because when this one has mapped to this, this has mapped to this, this has mapped to this. So our domain from there, domain is A, B, and what? C. And our codomain, not codomain, our range. Our range is what? Our range is a set of 1, 2, and what? 3. Our codomain is a set of everything here. Set of 1, 2, 3, and what? 4. They are telling us something different. They are telling us something different. In other words, domain is X, codomain is Y, and the range is what you are mapping. What you are mapping. Let's go back to that example I gave you. Let's go back to an example that I gave you. We are still moving. We are still moving. Those who are sleeping, you sleep. We are still moving. All right. We have already constructed the function y, or y equals to 15,000 plus 200x. We have already done that. Let's go back to that one. Let's go back to that one. So, in that one, since we usually call y to be f of x, we are saying where the f function of x is the same as y. All right? Function of x is the same as y. Since we usually do that, then we can come up with something like this. Because we are looking at that, then we can come up with something different now. So here, what it means there is this. Y is equal to f of x, which is y is equal to what? 15 what? 15,000 plus 200. This is our function. What do we mean? You have to know the meaning. You have to know the meaning. So the meaning there is, you say y can be the same as 15,000 plus 200x, or the meaning is this. F of x is equal to 500 plus 200x, like this one. That's the meaning. That's why we are saying this and this one are the same. This and this one are the same. F of x is equal to y, the same as y. So if you write y is equal to this, or write f of x is equal to this one, it speaks the same. It speaks the same. In other words, it explains the same. So, for example, if we use this one, f of x is equal to 1500 plus 200, right? X. Find f of 2. F of 2 is equal to 15,000 plus 200 multiplied by what? 2. You will get the answer, right? F of 0, what does that mean? Is equal to 1500 plus 200 times what? 0. F of negative 2 is going to be 1500 plus 200 times negative what? 2. F of t, what about f of t, is equal to 1500 plus 200 times what? T. Right? Take a matter of multiple choice. We'll meet on multiple choice. We'll see on multiple choice. All right? It's where you see that, oh, we were just playing, all right? F of P is equal to 1500 plus 200 times what? P. That's how we generate that. That's how we generate that. Now, all right. Now, note that x is the input variable and y is the output variable. That one, take note. So take note that, you have to note that x is the input variable and y is the output. All right, take note that x is the input what? Variable. And y is the output variable. All right. Now, what you have to do is, when you are around, can you search from the internet? I want you to define what is a variable. Define what is a variable. I want you to define what is a variable. What is a variable? And again, search from your internet the difference between independent variable and dependent what? Variable. Okay, we are proceeding. All right. Now, with this one, which is here, we can draw a graph. We can draw a graph. Right. Let us sketch the graph of this. And we see this graph of function. Let's go to that graph. All right. Now, our function y is equal to 1500 plus 200x. Let me define what is a line. If we have to define a line comprises of what? Points. A line, within a line there are points. Billions, there are many points in a line. But for you to draw a line, for it to make you find it very easy, what you have to do is, a line should compose of only 2 points. All right? Don't bother. A line should be composed of how many points? 2. But if you are to define what a line is, a line has got infinite, many points. Trillions, billions, quadrillions, whichever language that cannot be known, that is, those are points on a line. But I have simplified it to you to say that, my boys and my girls, in a line, just have only 2 what? Points. Point A and point what? B. All right. Then, let's draw a graph here comprises of 2 points. Point A and point what? B. All right. I still take you back to Form 4. I'm still taking you back to Form 4. That area where we came from, Form 4, that is a very nice place for us to be here because we have started from there. Now let's remember our home, Form 4. Now if you go to Form 4, if you are in Form 4, I still what the teacher was teaching you, that nice teacher, actually said, he taught you something about equation of a line. And what he actually said, he said something like this. Equation of a line actually said y is equal to mx plus c. Actually said like this. And then he was telling you that this m is the gradient. All right. So he actually said that this is the what? Gradient. And actually said that this is c is the y what? Intercept. Where the graph is cutting the y what? Axis. We can do the same to this one. So it's the same as y is equal to 200x plus 1500, like this. All right. What does that mean? What it means there is this. This is your gradient. It's a change, right? And this is your y-intercept, right? Where the graph is cutting the y what? Axis. Yeah. You have got 2 types of axes, right? You have got x-axis and y what? Axis. I don't think that I'm speaking French here. I'm speaking the language that you actually know. All right. Now, this is your y-axis, right? And this one is your what? X-axis. All right. Now, if you look at this is the 1500, right? 15,000, eh? All right. If that is the 15,000, let's come up with our scale. All right. We can come up with our scale. So our scale, it has to be, let's look at the scale. We can start with the 300, right? 5,000, right? So this is 0, 5,000, 10,000, and here 15,000. And then here, what? 20,000. Okay. Then we are saying a line should comprise of 2 points. The first point is this one. From this one, you make x equals to 0. Make x is equal to 0, then find what is your y here. 2, make y equals to 0, then find what is your x here. All right? When you make x equals to 0, it means the whole of this one is 200 times 0 is 0, right? Right? 0, right? Is that make x equals to 0? Any number multiplied by 0 is what? 0. And that is 0 plus this one, what remains there is 1500, right? 15,000, like this one, right? Therefore, this coordinate here, if you look at what coordinates will be, x is going to be 0 to 15 what? Like this one. This is the point, right? When x is 0 here, y is 15 what? Is here, right? It's there. That's the one point. The second point, make y equals to 0. If you make y equals to 0 here, what will happen will be like y is 0 is equal to 200 x plus 15 what? Like this one, right? Right? Then you take either this one, go this one, or take this one, go the other side, right? Then let's take this one to the other side, right? So it's going to be negative 2 what? 100x, yeah, is equal to this one, right? 15, like this one, right? And you want to find x. How do you find x? Divide by negative what? 200. And again, divide by negative 200. This, it gives you 1, right? All right, so x here is this divided by this one, right? So x is equal to, it has got negative, right? So that will be negative, right? Divide that by that one, it gives you what? 75. At the end. Yeah, negative, we have put that. This is the negative here. 15,000 divided by 200. Is it? Oh, this and this one, right? So this is going to be 75, right? Yeah, you know mathematics. Fine. Thank you. You know mathematics. Okay. So our x is this one, right? We go back to the graph. Our graph. If you go to our graph, let's look at our graph. What will be the down here? X. X is what? Negative what? Negative 75. Where is it going? Are you sure? Are you sure? Are you sure? Huh? Huh? Like which one? All right, let's look at it again. Yes. It's going to go which direction? All right. All right. If you look at this one, I was saying I defined I actually said, what if x is what? Yeah, what if x is, if we want to say, we want to find putting this y to be 0 there, that's why it is bringing as negative. Well, this one brings there as negative.